Hello, class. I'm here to talk about chapter 9. Um, we're actually going to be covering chapter 9, 10, and 11. Chapter 9, hypothesis testing, which one simple mean in proportion. And then on chapter 10, we're going to be talking about hypothesis testing with two simple means. Okay, we had this adorable picture over here, and it's telling you that let's say that you want to test or you want to decide if a dog breeder uh, claim that every Dalmatian has 35 spots. This is statistics sound. You could use hypothesis testing. So every time, just think as hypothesis testing as every time you have a claim that you wanted to prove either to be true or not true. Tell you an example that I heard once. Let's say that you apply for a job and they ask you how many words can you type per minute, and you say, oh, I can type 120 words per minute on average. Okay, and then they tell you prove it. So the moment that you put your claim out there, um, then we're gonna do where the person the recruiter who's gonna test your claim, either gonna uh, take the claim as acceptable and hire you, or he's gonna test that is not true, and then he's gonna reject, and he's not gonna hire you. That's another way you can think of is every time you have a claim and then you have your null hypothesis, and then you have your alternative hypothesis. You're giving a null hypothesis and you're giving an alternative hypothesis. So just think about the claim. Well, this is how usually you're gonna find hypothesis, the null hypothesis, the alternative hypothesis written. You can find it other ways. Uh, the equal sign you only find on the null hypothesis. You will never find on the alternative hypothesis. Okay, so there are a few tricks that I learned myself when back many years ago when I was learning all this. I got very confused, and I used to say, how am I supposed to know which one am I gonna use out of any of this? And then that's why I put this sentence to see if I can help you uh, to choose you be used based on your claim. So let's start over here. I was gonna assign number 62 for you to do on your own, but that's the one I'm gonna be using for the example. Okay, so let's see. Some of the following statements refer to the null hypothesis, some to the alternate hypothesis. Okay, and if we go to your book, you can see how they all call as null and alternative hypothesis. That's why you heard me saying alternative hypothesis. So it states the null hypothesis and the alternative hypothesis. Here we go, which is represented by this is represented by H. Uh, 0, and this is represented by HA in terms of the appropriate parameter of mean or proportion, which on chapter 9 we're going to be working with single mean and single proportion. So right here is talking about the mean. Okay, so let's read the first one. So the mean number of Americans work before retiring is 34. Again, the mean number, so you know you're working with the mean of years Americans worked before retirement is 34 years. So it's telling you it's equals to 34. It's not at least, it's not more, it's not less, it's not at most, it's 34. Which one out of all of this here has equal sign? So you're going to be using right here, this two. So you're going to be writing the A, the null hypothesis, or we call the claim, is going to be mu, because it's for the mean, correct? Equals to 34, correct? In our alternative hypothesis, Well, if we're testing if it's equals, the alternative is that our mean is different than 34. Okay, actually, I have to go here. Here you go. We answer A. I can even move up here. Let's try now B. So we're talking about at most 60%, again, at most 60% of Americans vote in the president elections. Well, first of all, we're talking about percentage. Every time you're talking about percentage, if you remember from the previous chapters, we're talking about a proportion. So we know that this sentence, this statement here refers to proportion. So we are testing a proportion. We're using a single proportion. Okay, so at most 60 is telling you includes 60, no more, no more than 60, but including 60 of Americans vote in the presidential elections. Which one here is less than or equal? Well, if you remember, all the null hypotheses are the ones with the equal sign, so we're going to be using these two statements right here. So B would be your null hypothesis, is going to be your proportion. In your claim, they call, let me put it here, and then they call, well, this, the null hypothesis is holding your claim because it's the one with the less or equal. So at least, at most 60%. So no more than 60%, including 60%. And then your alternative, it's going to be, if that one is less or equal, this one has to be greater than. Okay, we are not solving them yet. I'm just showing you how do you read the problems first, how do you set them up in order for to follow the remaining steps of hypothesis testing. C, the mean starting salary for San Jose State University graduates at least 100,000 per year. Pretty good, huh? So it's at least, that means it's 100 and more. It includes 100. We are talking about the mean. We already defined here, this is the mean, not a percentage, right at the beginning of the problem. It includes 100 and higher. Which one here of all these three includes, equals to, and higher? These two over here. So we're going to be putting, let me use this mean over here. We're going to be putting that the mean is at least 100 and higher, 100K, correct? Therefore, my alternative hypothesis, which I forgot to put it here, that doesn't help. Hypothesis is going to be the mu. So if the null hypothesis is higher or equal, the alternative hypothesis less than. There's no equal signs on the alternative hypothesis ever. Okay, so let me make it smaller here. All the equality signs goes on the null hypothesis. Let's try D. And I wish this was an exercise in class that you could follow along with me instead of just me telling you everything. So right here is 29%. So right here we're talking about a proportion of high school seniors get drunk each month. Well, it's telling you exact the amount, 29%. So we know we're dealing with proportion, but which one out of here, out of all these three, we have the equal sign over here. So if your no is equals, your alternative is different. So what we could do, let's use, no, yeah, I'm gonna use this two right here. But I'm just gonna change it by, it's a proportion and it's telling you at least 29%, not at least. It's telling you 29% is your proportion. Therefore, the alternative is that the 29%, they do not get drunk. That's what it says. Fewer than 5% adults ride the bus to work in Los Angeles. So fewer than is not telling you equals. It's just telling you fewer than. Which one would be your choice? So the only one that your alternative hypothesis, because it doesn't have an equality right here, is this one right here. So we are saying that, let's start with the claim. So the claim is, and we are talking about proportions. So fewer than, so your claim is that fewer than 5%. Therefore, your no hypothesis is going to have to be higher than, higher or equal than. Okay, you could also see as just equal. Next, F, the mean number, we know we're dealing with mean, of cars a person owns in her lifetime is not more than 10. Is not more than 10. So not more than 10, it's less, correct? But that includes 10 because not more than 10 is including 10. So let's do that. My HO, which one has the less than 10 including 10? Less than 10 including 10. Here we go. So be the mean here. So no more than 10. Actually, I should be using this. 10, correct? Therefore, my alternative hypothesis is going to be that my mean is actually then higher than 10 by using this. Let's try G. You're almost done. About half of Americans prefer to live away from cities given the choice. About half of Americans. Well, half of Americans, you got to be talking about percentage. Therefore, you're talking about proportion. So half, 100%. So half of them is 50%, correct? And it's telling they prefer to live away. So about half is giving you an equality right here. So we're going to be using this 2 over here. So my null hypothesis is going to be that my proportion is equals 50%. Therefore, my alternative hypothesis is going to be that my proportion, well, if my null hypothesis equals 2, then my alternative hypothesis is going to be different than 50%. The claim is this one right here. Let's start. Let's try H. Europeans have a mean paid vacation each year of 6 weeks. Have a mean paid vacation each year 6 weeks. Well, mean right there is telling you you're working with a single mean. I mean, you're working with the mean, and it's telling you they have a paid vacation each year of 6 weeks. It's telling you it's not less, not more. They're telling you it's 6. Therefore, if it's 6 equals to 6 for the null hypothesis, and then you're gonna have therefore different than 6 for the alternative. So we're gonna do my mean is gonna be equals to 6 months. Therefore, my alternative is gonna be that my mean, then in this case, is different than 6. 2 more, and we will be done with this. So now we have the chance of developing breast cancer is under 11% for women. The chance of developing breast cancer is under 11% for women. We're talking a percentage, therefore we're talking about proportion. Which one over here talks about under but not equals to? Under. Alternative is under. Your null hypothesis is going to be greater than or equal to. So your null hypothesis, it's going to be greater than or equals to, therefore your proportion 0.11%. Your alternative under, therefore less than 11%. And last now we have private universities mean, you're working on the mean, tuition cost is more than, it's more than 20,000 a year. It's more than, right here is not telling you, it's not including 20, correct? So we're going to be using this one's right here. So therefore, if your alternative, therefore, if your alternative is the mean is under than 20,000, your null hypothesis is your mean has to be greater or equals, since the null hypothesis holds the equal sign, 20,000. There you go. And this, I hope it helps a little bit as far as understanding the problems. When are you going to be using uh, the null hypothesis is equals and the alternative is different, the null hypothesis greater than or equals to, and then the alternative is less than, and then the null hypothesis as less than or equals to, and then the alternative hypothesis as higher than. And also make sure that when you're talking about percentages, you're talking about proportion, and then otherwise you're talking about the average or the mean. And one more thing I have mentioned before, and I'm gonna mention once again. When do you know that we're talking about a one tail test, a two tail test? The best way, the best trick that I can offer you is always to look at the alternative hypothesis. Okay, let's start with this one. Um, do you see the two little bars? That's the only thing I can think, a two tail right here. Let's just say this is a two tail. Here makes easier if you have your sign indicating to the left. See the little bic, the little point to the left, that would be a left tail test. And if you have your sign indicating or pointing to the right, your bic right here, your sign pointing to the right will be a right tail test. So if you are ever asked, how do you know in a hypothesis testing whether it's a left or right or a two tail, that's the best way I can show you to understand.